All right, so let's go take a look at the parametricization of 2 points. We've got the point -2, 3, which is point A here, and then we're adding on vector, and I guess I should have written it as 2 vectors, as 3, 6. So this is point B, here's point P. So what we've got is OP is equal to OA plus AP. So OP is equal to OA plus some scalar of AB. And this should have been an AP. Because remember, we know we've got a line. So that line it has to go through here, but it could extend further. So let's start substituting in what we have. So OP is what we're looking for. Here is O. So we're looking for X comma Y. Okay, the components of OA would be -2, 3. We've got some scalar T, and A to B had components. So you're at -2, 3, and then you're going 3, 6. So the components would be, so from -2 to 3 is actually a 5, and from 3 to 6 is actually a 3. So let's take a look at what we have then. In other words, X has got to equal -2 plus some scalar times 5. In other words, X is equal to -2 plus 5t. And then the Y is equal to 3 plus some scalar of t times 3, which again we're going to write as 3 plus 3t. And so now we've taken those 2 points and we've rewritten it. Those 2 points that create the equation of the line, we've written it with 2 parametric equations. And we can actually confirm that these points are on that line as well. So let's take a look at a t-value of 0. So if I plug in a t-value of 0 here, I have -2 plus 5. Which ends up being -2. If I plug in 0 here, I get 3 plus 3 times 0, which is 3, and that ultimately produces that point right there. Let's go and plug in another value. Let's go plug in t is equal to 1. So if I plug in 1 here, -2 plus 5 is 3. If I plug in 1 here, 3 plus 3 is 6. And I've ended up with that other point 3, 6, so we've confirmed it checks out. Now let's suppose instead of doing the whole line, all we want is the segment. We just want to restrict it to a segment. So that means we still have those parametric equations of -2 plus 5t, and y equals 3 plus 3t. The only difference here is our t values can go from -infinity to infinity because we wanted to get the whole entire line. In this particular case, all we want is the segment from here to here, and we ended up getting that. That produced, those were produced by these t values here. So we would restrict it from t is between 0 and 1. So 0 is less than or equal to t, which is less than or equal to 1. And again, if we wanted to, let's just go and confirm it using your graphing calculator as well. So let's go back to y equals. Let's go ahead and type in those 2 equations and confirm we get that equation. We get -2 plus 5t, and we've got 3 plus 3t. Let's go ahead and hit graph. Now you might be saying, well, why did it stop here? Well, if you go look at your t values, we had a t value of 0. So we could type in maybe -10 to 10. That should produce the whole entire equation of the line. Now, if I just want to produce this segment, remember, I'm going to go and restrict those t-values. And it's thinking because I had that really small step in there. So if I want to change this step back to a 1, that would still give me the straight line. If I want to go look at the segment, I go back into Window. I restrict it from 0 to 1. And now I get the segment that contained those 2 original points. Okay, this lesson's a little bit more difficult. Obviously, this one is especially. I don't think there's a whole lot of those. Again, at this point, a lot of it's just exposure because we know we can't go into major depth since we're not seeing you face to face. Post any questions on the discussion board and I will check that throughout the day.